When we decided on the site's wiki platform for the Molmodac project, we didn't do it just because we thought it was a neat technology or because we thought it was an easy way for you to create web pages. We decided on using the site's wiki because the wiki philosophy embodies a lot of the same ideas we wanted to accomplish with the Molmodac project, especially related to collaboration, creativity, innovation, and peer review. You should take the same approach as a Molmodac developer whenever you encounter any new technology. We'll be learning a lot about how to use JMol and Marvin Sketch and other programs throughout the semester as a means for visualization through Molmodac. But you aren't expected, and you shouldn't expect to learn every little detail about all of these technologies. Instead, you should think of ideas that you can use these visualization tools for, and then use your ideas to guide your learning of the tools. Using this approach, you won't get discouraged by the vast array of things we can do with tools like JMol and Marvin Sketch. As I take you through this example page, I'll talk about my ideas and how I use JMol and Marvin Sketch to bring these ideas into fruition. Take for instance these JMols, which are meant to show the interactions of CAMP with the regulatory subunit of protein kinase A. The two JMols at the bottom are large views of the entire protein, and I used colors to highlight the various domains that serve different functions within pKa. Specifically in the bottom right structure, I used ball and stick models of specific amino acid side chains to show an important interaction in the protein. For the purposes of content related to Chem 332, I think it's the JMol above that actually shows the most detail. So here you can see a molecular level view of CAMP binding to specific residues in the active site of the protein. I've used the JMol measuring tool to show interactions between portions of the molecule and the residue side chains, so that a viewer who knows something about the typical distances for these interactions can see that it's reasonable to propose these interactions as the driving force for CAMP binding. I used Marvin Sketch here to show some reaction steps related to the biosynthesis of CAMP. On the right here, I essentially just drew out a reaction sequence and used curved arrows to show the electron flow associated with the biosynthesis of CAMP. Notice that these arrows should probably look very familiar to you and really highlight information that we learned in Chem 232. This Marvin Sketch on the left may look quite jumbled to you at first, but clicking on it, what you can see is that it represents a three-dimensional model of the transition state for the formation of CAMP. By using Marvin Sketch's Clean in 3D feature, I was able to build the transition state in 2 dimensions and then allow Marvin Sketch to calculate the 3-dimensional geometry that would most likely result from this transition state. This page was put together relatively quickly, but hopefully you can see the way that I used the chemistry to guide my thinking about the technology. I first of all thought about what I wanted to do with the molecules and how I wanted to display them, and only then did I go to JMol and Marvin Sketch and actually figure out how to make that happen technologically. Take a look at this Springboard example in more detail to jumpstart your own Molmodac page as you get started.